Okay, so sketch the graph and show all intercepts, and I purposely didn't put like the vertex or center point. You need to find that whether I ask for it or not is the point. If I ask for the intercepts, then I'm looking specifically for those, but in order to draw the graph, you do need all the important points on there, okay? So let's say y equals x plus, absolute value of x plus 2 minus 4. Okay, so we need our vertex, or the center point, which would be what? Negative 2, whatever makes this 0. It's not the number that's in there with the opposite sign, but whatever makes the inside of the bracket 0, so negative 2, and then negative 4. And we know that our basic graph is an absolute value of v, and this one is moved where? Negative 2 and negative 4 down here. Is it open up the same way? Yeah, how would you know if it wasn't? A negative in front of the, that would be the only difference, a negative in front of the absolute value. So it's here. Is it going to pass through all the x and y axis? Yeah, so we do need to find all the intercepts. So our x-intercept, we'll let y equal 0. So move the 4 over. Or if you like it better this way, you can write it that way. Okay, so just like with a parabola, this is going to have 2, right? It's sort of the same shape, it's just that it's pointy. And the 2, instead of using a quadratic equation or factoring, the 2 answers come from the 2 cases that the absolute value could be. So case 1 is that the inside of this bracket is a 4, because the absolute value of 4 is 4. Or case 2, the inside of the bracket is negative 4. So we solve both of those, and that'll give us our 2 points that it goes through. So 4 minus 2, and minus 4 minus 2. So write them as points, if we're looking for them as points. The y is 0, because that's what we did to solve them. We let y equal 0. That's how we solved it. And then our y-intercept, let x equal 0. So y is 0 plus 2 minus 4. The absolute value of 2 is 2. X is 0 and y is negative 2. So we've got all the points we need. There's 4 in this case. The 2 x-intercepts, the y-intercept, and the center point. So negative 2 all the way down to negative 6. 6, positive 2, so the x values. The y value is negative 4, negative 2, and 0. Okay, so that should do it. So our first point, negative 2, negative 4. And then it's a v. This is our vertex. So 2, 0, and negative 2, 0. Or is 0, negative 2. And then on the other side is negative 6. So that was 2, 3, 4, 5, 6 right here. There we go. That was the third sketching question. I think we did 2 others in the last part. Okay, so here's the next one. The cube root plus 1. Now this one is just easy. This would be more like a 1-point question. There's really not much to do. Like what we'll do the whole process for it. But if we were drawing this, what's the regular cube root look like, the basic graph? it's two parabolas, or two half parabolas on their side, like that. What does the plus 1 do? Moves it up 1. So really, the graph would be here and there, and what do we need to find? Just that point, right? And then you would be done. This would be considered just a 1-point question because there's really not much to do in this. So we would say that our vertex, or our center, is the point 0, 1. 0 because there's nothing added or subtracted under that, and then 1. And then we need our x-intercept. That is the y-intercept, so you wouldn't need to find another y-intercept because it's only going to have 1. Our x-intercept, if we let y equal 0, what did we do to each side to get rid of a cube root? Cube each side. So they cancel, that's x, equals negative 1 cubed is negative 1. And there would be our graph. Okay, let's do a hyperbola. So hyperbola itself, to do the whole graph, and that wouldn't be a 1-point question because there's more to it, but I could ask just for the intercepts of a graph or just for the asymptotes of a graph, and that could be part of that. Could be, so if I put this question in the first part of the test where the questions are just worth 1 point, then we might say find the vertical and horizontal asymptote, 1 point. So what would be the vertical and horizontal asymptote? So the vertical asymptote is the restrictions, because it's a fraction, so whatever the restrictions are on the domain, that's the numbers that don't work. So when we have a fraction, the number that does not work is what makes the bottom 0. So we'd say x minus 3 equals 0 gives us x equals 3. That's the vertical asymptote. And the horizontal asymptote is, there's more to it in real life, but in these particular functions, it's just that number here, which is y equals 2. So that would be it. Basically, it's the y value that we can't get an answer for. This can't be 0. So we can't have y equals 0 plus 2. That doesn't work. We won't be able to get a 0 there. So then we can't get 0 as an answer. So there's our horizontal and vertical asymptotes. Now, if we just draw those in, vertical x equals 3, 1, 2, 3. Put them in as a dotted line, and you can label them. And y equals 2. So remember our basic graph is here and here. When does it flip to the other? If it's negative. So there could be 2 places a negative could be here. It could be on top with the 2, or it could be in front of the x. And is either of these negative? No. You don't need to worry so much about that, because when you find your intercepts, it will show you. Because if they're not where you thought they were going to be, you can say, oh, is there a negative there? Oh, that makes sense that they're not where I meant. So our graph is going to be, and we're looking at not the x and y, we're looking at these dotted lines. So it's going to be up here and down here. I'm not going to draw it in down here yet because it's going to cross both the x and the y. All right, so let's find the x-intercept. We let y equal 0. Move the minus 2 over. cross multiply.
Why is the right side -2?
When I move this over. Oh, it's not supposed to be. Thank you. It's not supposed to be. Okay. Now what? FOIL that out. Minus 2x plus 6. Okay, so 2, 0. And then our y-intercept. What, x equals 0? 2 over minus 3 plus 2. How do we get that into a number? Common denominator. That minus doesn't have to be on the bottom. It can just be in front or on top. So this is minus 2 over 3 plus, that's like over 1. We multiply it by 3. 6 over 3. Minus 2 plus 6. 4 over 3. That was our y value we just found. So 4 over 3, that's a little bigger than 1. Okay, so let's go back to the drawing, our graph, and put these points on. So x is 2, 2, 0 is here, and then y is 4 over 3, so here's 1 and a third is right there. Now, I'm not asking you to do anything over here, but you could. What if we wanted a point over on this side? What could we do? Yeah, always. You can do a table of values for any of these. You can plug in any x value. What would be a good x value on this side? So that's 3, so what about 4? So if we plug 4 in to our original, so 2 over 4 minus 3 plus 2, 2 over 1 plus 2 is 4. So the point 4, 4 is just an extra point, but you could do a couple points over there if you wanted to. Sometimes it's worthwhile to plot a few points if you're unsure. And you can do that for any graph. Just plot a few points and make sure what you got matches, or if you're unsure about the graph, you can plot a few extra points and just make sure, or you can start that way. You can start with the table of values and then go through what you think and see if it matches up. So there's lots of time on the test to do stuff like that, but you do need to make sure you answer the question. Like if I ask for the intercepts, you want the intercepts to be part of it. But you can always do a table of values anytime you're graphing, just to be sure you've got it right. Plug in any x value and solve for y. Okay, chapter 3. So this will be question 7. Yes, we did 6. 6 was the graphing. We had started it last class. All right, I'm just going to write a few down here. Okay, ln of E. 1. You just have that memorized. But it's log, this is the same, it's just 1. But ln, yeah, is the same as log base E. So if we have ln e, that's the same as log base e of e, which they match and they cancel out, and the exponent would be the answer. So that's just one. What about this one? Log base 3 of 9, which is 3 squared, they match, so the answer is 2. These would obviously be one-point questions, right? Nothing really to show. Now what about this one? Is 20 a power of 4? No. Is 5 a power of 4? No. Can we combine them to a single log? Yes. And when there's a minus in between, what's the rule? Divide. So you write one base, one log, and then you divide the two arguments. So this would be 20 divided by 5. What's 20 over 5? 4. Now what's the answer? 1. Great, a little more to it, but still just a one-point question, right? Okay, D. Now, there is base 5 and a 5 here, so they do match, and 5, what's log base 5 of 5? 1. So this last part is just 1/2 times 1, which is 1/2. What about this part? What's a square root as a power? 1/2. So these cancel, that's just 1/2, and this is equal to 1, so that's minus 1/2, so what's the answer? 0. 1/2 minus 1/2. All right, so these cancel, that's 1/2, and this cancels, so that's minus 1/2. 1/2 minus 1/2. Yeah, if I put a plus sign in there, then we could have had 1 as the answer, 1/2 plus 1/2, something like that. Okay, so that would be evaluate. Now let's do solve for x. Actually, let's add another one in here. Make it a little bit different, but it's still just evaluating. Okay, so it's still evaluating. We're plugging a 0 in here and we're finding the answer. So the first one, f of 0 would be 2 times e to the 0 plus 3. What's e to the 0? 1. So that would be 5. Now what about plugging a ln 2 in? 2 times e to the ln 2 plus 3. Well, e and a ln touching, those are opposites of each other, so they would cancel. So this would be 2 times 2 plus 3. No, that's 2 times e. Oh, no, that's what the answer would be. Right, e times ln of x is x, or e times ln of 2 is 2. Yeah. So that would be 7. And a negative 1. Nothing to do here. 2 over e plus 3, that would be it. There's nothing to cancel out with the e, there's no ln in there. E to the negative 1 is 1 over e. That would be as far as you could go with that. Okay, so we'll go through each type of solving for x. So the first one is when you can make the bases equal, and here what could we make both bases? Not 4, because 4 squared is 16, so 2, right? So 4 can be written as 2 squared, and there's an x plus 1 there, and 8 can be written as 2 cubed. Right, so now the bases match, so we can say 2 times x plus 1, the exponent, is equal to 3. That would be it. Okay, so as opposed to this example where you can't make the bottoms or the bases the same, so what we need to do is do something to both sides to get the 3 to cancel out. And what is that? Log base 3. So we take the log base 3 of both sides. Then these would cancel, and we would have 2x minus 3 is equal to log base 3 of 7, which is a number. You don't do anything to the 3 or 7, that's just by itself. You could even stick it in a little bracket to make sure you don't do anything to it. Okay, now how do we solve for x? Add the 3, and then divide by 2. And like I said, don't do anything to that. That is the answer. Okay, so the next is log, but the log on each side has the same base and there's nothing else, no other terms. So what do we do? So these are the same base, same. So we can just, not really even cancel them, just ignore them because they're already equal, so the inside of the brackets would have to be equal. So 2x minus x equals minus 1 minus 1. Now, with a log question, just like a square root, those two examples, and sort of a fraction, you have to make sure you can plug it in. We need to make sure that it works, right? That when we plug it in, it works. So we do need to check our answer when the original question is a log. We didn't do it up here because exponentials can have they can have a negative exponent or positive or a 0. They can have any exponent. The domain for an exponential is all real numbers. You can plug anything in, so it doesn't matter what the answer is, it's going to work. But with logs, you can't have negatives or 0. So, if we take our negative 2 and plug it in, what happens?
Negative answer.
Right, here we'll get log base 7 of minus 4 plus 1. is log base 7 of minus 3, so that, no, we can't have that. We don't need to check the other side, it already doesn't work. If it doesn't work in part of it, it doesn't work at all. So this is inadmissible. So what would the solution be? The solution is no solution. Right. Nothing. Those two logs can't be equal. There's no value that will work. Okay, so this would be the next type, is that we have just a single log, so we can't sort of compare them and cancel. We have a single log, and a log can equal a negative. It just can't have a negative in as the argument. So what do we do to get rid of the log base 5? Raise it to the power of 5. So we put that 5 on both sides, and these are now the exponent. That would cancel. We would have 2x plus 1 equals 5 to the negative 1, which is 1 over 5. One over 5 minus 1. So that's 1 over 5 minus 5 over 5. The common denominator. And then what do we do with the 2? Cross multiply. Two times 5, 10. You can reduce that. Now we need to check it. Because the first question started with a log. So log base 5, 2 times minus 2 over 5. Is that negative? Minus 4 over 5 plus 1? No. It's positive. All right, if you did a common denominator, minus 4 over 5 plus 5 over 5, what do we get? 1 over 5, and that's okay. And if we wanted to keep going with that, we could say this is 5 to the negative 1, which is negative 1, which is what we had. Okay, so the next type, when there's sort of 3 terms instead of just 2 with a log involved. So if there's 2 logs and they're related with a minus, we use that division rule. So we would rewrite this as log base 2 of x minus 2 over x plus 2. And now we're back to the example like we just did with one single log. So we raise these as a power, and the base is 2. So this would be 2 to the power log base 2 equals 2 to the power 2. What you don't want to forget to do, where people go wrong here, is that they sometimes put this one to the power, or this, they put a power 2 and they don't do anything with that. They just rewrite it instead of putting 2 to the 2. And to solve this, we cross multiply. Okay, so if we check, so minus 10 over 3 minus 2, I can see already that that's negative. I mean, you have a negative number and you're subtracting more, so it's still going to be negative. We can't be positive. So that would be inadmissible, so there's no solution. I don't need to check further, because this is negative, we can't have a negative. It doesn't matter what happens here, it already won't work in part of it. So do make sure you check your answers. Okay, question 10. Okay. Trig. So I've got 4 questions written down here. And if they're just memorized and you just can put the answer, there's no work involved. And anyway, these would be 1-point questions, so I wouldn't be looking at what work you did, so you can draw your angle and find your reference angle. Or if it's memorized, like sine of pi over 2 is just one of the ones we know, which is what?
1.
It is 1, right. Now, even if you didn't write your table, you can think about that, because sine of 0 is what? 0. That's where we start our table, 0, 1, 0, 1 for sine, and it's the next one, right? So when we do our table, this is back to the start, so these answers are equal, but this goes 0, 1, 0, 1, 0, and the second one is negative. And then cos is the opposite, 1, 0, 1, 0, 1, and the second one is negative. Right, so you just have to remember the values as you go around the axis. And so we would just write 1 here, and that would be it. What about this one? So this we actually have to find and think about it a little bit more. But cos, so we would draw our angle, 2 pi over 3. So we take our pi, cut it into 3 pieces, ignoring that line. And we want 2 of them. 1, 2. So here's our terminal arm. Our reference angle is in here. And that's 1 piece, so it's pi over 3. So we look up cos of pi over 3, which is, anyone know? 1 over 2, it is 1/2. And are we positive or negative in that quadrant for cos? Sine is positive, so that means negative. So negative from the S, 1/2. So this is a work, you can show it or not show it, right, depending. I always just do it quick myself. So, you know, I would just normally draw this, and then I know that that's pi over 3, so I'll write the 1/2 and then the negative. I don't write down reference angle and that, but you can if you want. So what about this one? Secant is the reciprocal of cos. So we already have the answer for cos, so we flip this one over. Negative 2 over 1, which is just negative 2. Oh, right here. Thoughts? It's an identity. What's sine squared plus cos squared equal? 1. It doesn't matter what the angles are, as long as they're the same as each other, the answer's 1. You don't need to do anything. You could work them both out. Find sine of pi over 4, and then square the answer. Find sine of pi over 4, or cos of pi over 4, then square the answer, and then add them together, which will give you 1. But no need, it's an identity, the answer's just 1. That's sine squared plus cos squared is equal to 1 always, as long as those two values are the same. Okay. You could say like, or, if you did sine of pi over 4, sine of pi over 4 is 1 over, or is root 2 over 2. Square it. Cos is also root 2 over 2. Square it. If we square root 2, 2 over 4. Square this one, 2 over 4. 2 over 4 plus 2 over 4. You could work them out, but you don't need to because it's an identity. Oh, this should say simplify. That's the instruction, not evaluate. We're not finding an answer, we're just simplifying, so. Let's call this a question 11. Simplify. Okay, so what do we do? There's square root. We can't take the square root of the 9 and the other yet because of that plus sign. When we have a square root, it has to be multiplied in order to break it down. So we can factor out the 9. And what's 1 plus tan squared? That's an identity. Right. 1 plus tan squared is secant squared. So this will be 9 secant squared, and then we can do the square root of each piece. So we'll call that A. B, show that sine 2x over cos x plus 1 over cosecant x is equal to 3 sine x. Okay, so one thing is always the same. You need the argument of the trig or whatever comes after the trig to be the same, and we've got a sine 2x. You can't factor that out, but there is an identity for sine 2x. What's the identity? Sine 2x is equal to 2 sine x times cos x. Okay? Now we can rewrite, so we're looking only at the left-hand side, and we're trying to get it to look like the right-hand side. So if we start with sine 2x over cos x plus 1 over, I'm just rewriting it, cosecant. So sine 2x cos x is 2 sine x cos x. Now the other thing that's good to try is to convert things to sine and cos. What's 1 over cosecant? Sine x, yeah. 1 over cosecant is sine x. They're the opposite. The one that starts with c is the sine, and the one that starts with s is the... So this is plus sine x. Now what happens to this first term? Coses cancel. There's a cos x on top and bottom. So we have 2 sine x plus sine x, which is what? 3 sine x. 2 plus 1 is 3. Just one. Just one. How many questions like these are on the exam? The identity one's just one. Okay, so what do we do here? Convert things to sine and cos. So secant is 1 over cos, and cosecant is 1 over sine. So we're going to replace those two. So the cos on top is going to stay, and then secant is 1 over cos. Sine is going to stay, and cosecant is 1 over sine. Cos divided by 1 over cos. So we take the top, multiply by the reciprocal of the bottom. Same here, take the top, multiply by the reciprocal of the bottom. Cos times cos, cos squared. Make sure you put the squared between the cos and the x. And sine times sine. Cos squared plus sine squared? 1. And on the practice questions, so I'll have a list of practice questions for you to try for the final. These will be on here, but they aren't on the homeworks that I assigned. Okay, but there is one of these on the test too, something like this. Okay, so it's just working backwards. So you say, forget about the sign, because that's the cast rule. Whether it's positive or minus is the cast rule. So the cast rule we need, and that's for the negative sign. So which quadrant is negative for cos, because this is a cos? The S or the T are the negative ones. So that's the two quadrants we're going to draw our angle in. And that's it. We're done with the sine now. Okay, that just tells us what quadrants we're in. And now we're looking at, where does cos equal 1/2? What angle? You may not know right off, you might need to draw your table, but cos is a 1/2 at pi over 3. Okay? So you would find that in your table, looking backwards. So, you know, we've got sine, cos in our table. Right? 1, 2, 3. So in our table, here we're just looking backwards. We're saying, okay, here's cos and here's 1/2. What's the angle? It's pi over 3. So that's our reference angle. So what we do is draw that angle in those two quadrants. So that angle, pi over 3, here and here, as a reference angle. So the angle, it's always between the x-axis and whatever your line is. So I just drew the line, the terminal arm, and I put the pi over 3 in. So our start is here, and if we go around, we say, okay, what is that? How big is that piece? So remember, this is a Joe Louis. This is 1/3 is cut out. How many thirds would this be? 2/3. So 2 pi over 3. So 2 pi over 3 would be our first one. And then what would be the next? So still from the start, but going all the way to here, how many thirds would that be? So this is 3 pi over 3, that's 3 whole pieces and one more. So 4 pi over 3. How many values do we want? 5. We could keep going around positive, or we could go negative to find them. So what would the, let's do one negative one to see. So here's our start. In case, I could say find 2 positive and 2 negative values, so you need to know how to do both. So if we go backwards from our start, how big is this piece? Right, this is 1 pi is all the way to the end, and we have 1 piece less, so this is 2 pi, but it's negative because we went in the negative direction. So negative 2 pi over 3 would get us to that line. And the next one? Right, so right to here, from the start backwards is 3, and 1 more is 4, so negative 4 pi over 3. And I did this on purpose, I said 5 values, so you have to pick one more. You could go forward, you could go backwards, it doesn't matter. You can add on, or you can just go back to the start and start counting a new one. So what you need to do is go further. So let's say we went from our start all the way around. What's that? How many pieces? 6. And then to here. 6, 7, 8. So there would be another one. Right? So just go all the way around and then go to one of the lines, or go all the way around backwards, negative 6, and then to the next. And you could keep doing that if we wanted more values. Keep going around and around. Okay, and I tried to match those up with color so you could follow each one. Okay, so let's do one more of those. Okay, so they don't have to land inside one of the quadrants. They could land on an axis, right? Where does sine equal 0? At, think of your table. 0, pi over 2, pi, 3 pi over 2, 2 pi. 0, 1, 0, 1, 0. Whoops, that one's plus. Second one is negative. So here's three values already. All right, where does sine equal 0? Well, sine is 0 here, here, and here. So x could be 0, pi, or 2 pi. There's 3. How would we get any more? Well, here's 0, pi, 2 pi, here, here. What would this one be? And this one? 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. What about backwards? If we're at 0 and we go this way, negative pi, negative 2 pi, this is way more than 5, negative 3 pi, right? So you can land on an axis and do it the same way, but you don't need to worry about the sign. The cast rule doesn't apply when you land on an axis, ever, because the sign is just wherever you land. So, for example, if I wanted to find cos of 7 pi over 2, well, pi over 2's land on an axis. If I wanted to just find, to evaluate this, get the answer to that. So pi over 2 is here, a half, right? And we want 7 halves. So where would that land? So that's 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. It lands in the same place as 3 pi over 2. Right, 1, 2, 3, 4, 5, 6, 7. We're back to here. So all you need to look up is cos of 3 pi over 2. You don't need to worry about the sign, because the sign is taken care of when we're in our table. Cos goes 1, 0, 1, 0, 1. So what's 3 pi over 2? 0. You don't need to worry about the sign. The sign will be taken care of when you look your value up. Okay, so that's everything in the course.